When solving logarithmic equations, it's sometimes necessary to condense the logarithmic expression into a single logarithm. We're going to practice some of those condensations, and we're going to need some log properties. Make sure you can write those log properties from memory. Let's illustrate some of them right here. So let's say log base b of x to the p power. One of the log properties says we could take that exponent and move it into the coefficient position. Since we're condensing, we actually want to think of it like this, because we tend to read from left to right. So let's put the coefficient first. P log base b of x is equal to log base b of x to the p. Another useful condensation property would be log base b of m plus log base b of n. That is going to be what? Log base b of m times n. We also have log base b of q minus log base b of r is equal to log base b of q over r. That's a b, not a 6. With all these properties in mind, why don't we try to condense these expressions? Keep in mind you're just trying to manipulate this expression. We're going to manipulate the expression in part A to look like something else. Remember to use order of operations. Order of operations says perform what's in the parentheses first. So we're going to put that 4 as an exponent on the x. Is there anything else we could do? Yes, we're still working with parentheses, with order of operations. We have a subtraction of logarithms with a common base. That really means, what does that really mean? I'm going to write log base m of w over x to the 4th. And of course, x can't be 0 there. Now we're in good shape. We're going to take log base m of z, put that to be z to the 3rd power, plus log base m of w over x to the 4th, raise that to the 2nd power. And we have one more log property here, log base m. And what are we going to write now? We are going to write a product. We have z to the 3rd times w squared over x to the 8th. I guess I could use parentheses there. And there's your single logarithm. You try part B. Change this expression. Change the first expression to look something like this. And now we break the order of operations by working left to right. Notice we only have addition operation and subtraction operation, and we break that tie from working left to right. So this is log base 5 of x to the 1/2 power times w to the 4th power minus log base 5 of y. One more log property here, log base 5. I'm going to write parentheses, square root of x, w to the 4th power over y. And of course, y is not 0 here. We already knew that, by the way. Y is greater than 0, w is greater than 0, x is greater than 0. So we already know y is not not 0. Same thing with the first problem. X is greater than 0, so we know x is not 0 down here. Let's look at part C. Well, these are very, very similar. First thing we do, is take that coefficient and put that up as an exponent. Same thing with the second expression. And now we just have one more log property to go. A logarithm with a common base, and there's a subtraction operation. That means we'll do something like this. X minus 7 quantity squared over x plus 7 quantity squared. And go ahead and leave that in factored form. Those are factored. Let's circle our final answers. Remember, all you did with these problems is manipulate the original expression. You manipulated the original expression. You just changed the way it looks. So if this was Batman, this might be Bruce Wayne.